Hello, this movie is on Learning Target 2, Reflections of Figures on the Coordinate Plane. This is for part 1. Opposite orientations. Two figures have opposite orientations if the corresponding vertices of the pre-image, which is where you have the original figure, and the image, where it ends up, read in opposite directions. So you can see here that when you reflect, you get an opposite orientation. When you reflect a figure across a line, each point of the figure maps to another point in the same distance from the line of reflection, but on the other side. The orientation of the figure reverses. So you can see that happening here, where if I'm taking point B and I want to reflect over this line of reflection right here, two things will occur. First, B, if I take this distance to the line of reflection and I travel at a perpendicular path, I will get, B prime on the opposite side. So that's the first thing, is that you want to travel at a perpendicular path to the line of reflection. The second thing is the distance that B takes from the point to the line of reflection will be the same as the distance on the other side. So those are two big things you need to know about reflections. If the point is on the line, it stays on the line. A and A prime are both the same. C to C prime is the same thing. If you travel in a perpendicular path to the line of reflection, you will get where C prime is, and these two distances are exactly the same. Here are the properties written out. Reflections preserve distance, meaning the length of BC is the same as the length of B prime C prime. Now these of the image right here have the primes, and the ones that do not have the primes is the pre-image. So remember that from our first learning target. Reflections also preserve angle measures. So the measure of angle C is congruent to the measure of angle C prime. Same with all the other angles. Reflections map each point of the pre-image to one and only one point of its image. So if I take B and I'm going to reflect over this line of reflection here, I will only get one point B prime. Here we used tracing paper and we realized that down here that the line of reflection, the fold was the line of reflection, and it was a perpendicular bisector. A line of reflection is, and I'll show you that with this because you don't have paper, the line of reflection is perpendicular to the line connecting the pre-image and its image. So it's perpendicular, and not only that, it's bisecting that. So we say that the line of reflection is a perpendicular bisector to the connection between a point and its reflection. How can we prove that these figures that you see on this graph have actually been reflected over this line x equals -2? Well, you can connect A to A prime. And when you connect, if two things happen, first of all, it's perpendicular, which it is because we have a horizontal and a vertical line, and those lines are perpendicular. And then the second thing, that the distances are the same. This is 1, 2, 3, 3 units. This is 1, 2, 3, 3 units. So we have that the line of reflection, which is x equals -2, is a perpendicular bisector between A and A prime. Is that true of all the points? Well, you could test it out if you wanted to. Perpendicular bisector, same with B, same with C. So yes, that's how you test it out. See if the line of reflection is a perpendicular bisector. Reflect this point -4, -2 over the line x equals -2. What do you get? Well, we're going to travel at a perpendicular path. We go 2 units, so we go 2 units to the opposite side. C prime is here. You travel at a perpendicular path and you go equidistant on the other side. So the vertices here are 0, -2. Now we're going to reflect over the y-axis, and you know that the y-axis is this vertical axis here. So you can see that this figure is reflected over the y-axis. We got A mapping to A prime, B mapping to B prime, so on and so forth. The input of this function are the original, the pre-image. That's here, pre-image. That's without the primes. And the points are located at A is at -4, 7. Write that down. B is at -2, 5. C is at -6, 2. The output is the image. And the points for the output are A prime is at 4, 7. B prime is at 2, 5. And C prime is at 6, 2. So the question is, what did I do to the points A, B, and C to get to their primes? What happened to -4, 7 to get 4, 7, -2, 5 to get 2, 5, and -6, 2 to get 6, 2? Well, you can see that the x-coordinate has changed and became its opposite, but the y-coordinate stays the same. So in the pattern down here, which I would star, this is a pattern that you need to know. A reflection over the y-axis will map xy to the points -x, which means the opposite of x. And you can see if it's positive, it becomes negative, and if it's negative, it becomes positive. Why? Because y stays the same. So that's the pattern for reflection over the y-axis. This slide here has two separate questions, so keep that in mind. These are not the same things. The first one here, we're taking A, B, C, D, and we're going to reflect over the y-axis. So we're going to take each point and reflect it over the y-axis. A is located here. We're going to travel a perpendicular path, and we went 1, 2, 3, 4 units. So we're going to go 4 units on the opposite side. It's perpendicular to get A prime. B is on the right, so it's going to travel and be reflected on the left side for B prime. C is on the left, and it's going to travel to be on the right, C prime. And then D moves, I think that's 8, and then we go 8 here to get D prime. And then we connect those. Make sure you're doing that on your document. Use a ruler. Doing these freehand is a little crazy. Okay, pause the movie, try that on your own. Press play when you're finished. Okay, going down here, state the coordinates. So if we just have coordinates, not a coordinate plane, we're going to use the pattern, which a reflection over the y-axis is the point xy maps to the point -xy, which means the opposite of xy. So if A is at -7, -4, A prime becomes the opposite of -7, which is 7, but the -4 stays the same because the y-coordinate does not change. B being at 0, 1, 0 doesn't have an opposite, so it stays 0, 1. C is at 2, -8, which becomes the opposite of 2, -2, and the -8 stays the same. Okay, give yourself a minute to write that down, and then let's go to the next slide and reflect over the x-axis. Now the x-axis is this horizontal axis here. So let's get our coordinates for this, which is A is at -4, 7. B is at -2, that's -2, 5. And C is at -6, 2. Get the coordinates for the primes. Write those down. And then let's look for a pattern here. What happened to point A to get A prime? -4, 7 became -4, -7. -2, 5 became -2, -5. -6, 2 became -6, -2. Well, in our pattern, the x stayed the same. but the y changed. The y became its opposite. So we say that xy maps to the point x negative y. And that's how we represent the pattern for a reflection over the x-axis. So that's what we're going to do here is use this pattern for the x-axis. We're going to graph the reflection of this guy over the x-axis, which is here. And the same thing is happening. So we're going to take point A, count 1, 2, 3, 4, 5, 6, 7, 8, 9, and do the same on the opposite side to get A prime. B is up here. It travels 1, 2, 3, 4, 5 to get B prime down here. C and C prime stay the same because it's on the line of reflection. D is down below, so it travels up top because it goes in the opposite direction. 1, 2, 3, 4, 1, 2, 3, 4. And we get D prime is up here. So mark that on yours, connect, use a ruler. Pause it, press play when you're finished with that. Okay, number 2 is different. And we can see that we've got coordinates. So we're going to use the pattern, which a reflection over the x-axis is point xy will map to the point x negative y, which means the opposite of y. So negative 7, negative 4 becomes negative 7, 4. 0, 1 becomes x stays the same, but y is its opposite, so 0, negative 1. C, which is 2, negative 8, becomes 2, positive 8, because it's the opposite of y. Okay, pause the movie, make sure you've got all that written down, and press play when you're finished. Okay, because we're in part 1, we are going to save the reflection over the line y equals x for part 2. Or actually, I'll come back to it at the end. But if you're watching this from class, this is probably day 2 is that reflection. So I'm going to go to the next page. We are able to do this one, which is a reflection over the y-axis. And if I'm going to take each of these points, reflect over the y-axis, that is... Actually, I'm sorry, pause the movie, do that on your own, and then press play when you are finished. Okay, so hopefully you did that on your own. You got to graph it and write the coordinates. So the y-axis is this axis. So hopefully you learned to reflect over that one. Point A, which is here, goes 1, 2, 3, 1, 2, 3. A prime is here. So if you had used the wrong axis, try it again. Let's go over here. Should look like this. Reflection over the y-axis. There's your graph, and here are your points that you should have. So check yourself. Then let's go back here. We're also able to do, so we've got this one done. We're also able to do this one down here. Reflect over the line y equals 3. So we have this little saying, hoi vux. I like it because, I'll show you in a second. I like it because H stands for horizontal line. And we know that a horizontal line goes from left to right. The slope of a horizontal line is 0. And the equation is y equals a number. So this equation, y equals 3, will be a horizontal line. Vux, in comparison, will be a vertical line, has the U stands for an undefined slope, and its x equals a number. So if I had x equals -2, I would know that that's a vertical line. In this case, it's a horizontal line, y equals 3, 1, 2, 3. And so that is this line that we're going to reflect over. So pause the movie, try that on your own, press play when you are finished. Okay, hopefully you have tried that. We are now looking at your answers. See how you did. Also note the coordinates. You should be able to write these as well as graph it. Okay, so that's it for part 1. We're now going to go over part 2. And the reason for adding this to the movie is probably in the classroom, this is day 2. So part 2 is going to be using reflections over the line y equals negative x. The first thing you need to know is how to graph the line y equals negative x. It is this line right here that you see. Negative x, y equals negative x, y equals x, has a slope of 1 because in the form y equals mx plus b, m is your slope. So the slope here is 1. The y-intercept is 0. So if we start at 0 and we go up 1 to the right 1, 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 you can see that we get this line right here. So that's the line y equals x using our Algebra 1 skills for graphing. If we take our original pre-image ABC and we reflect it over this line, which is no longer horizontal or vertical, we can do the same method visually. We can take point A, we can travel at a perpendicular path. Now, in this case, the slope is 1. So a perpendicular slope would be negative 1 over 1, which is 1, negative 1. So if we travel down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, we travel in this path, we will get what A prime is. And you can see that we end up with A prime over here. So if I went 1, 2, 3, 4, 5.5 diagonals, I'll do the same over here. There's a half. 1, 2, 3, 4, 5. I get A prime. So A maps to A prime because it's traveling at a perpendicular path, which is a slope of negative 1, and it went 5.5 diagonals, so I do 5.5 diagonals over here. B is going to be in the same path, and it's 1, 2, 3.5. So I'm going to go half, 1, 2, 3 to get what B prime is. Pause the movie, try that with C, verify, and then we'll press play when you're finished. Okay, C's traveling perpendicular path 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals to get C prime. So even though it's not 4 units, it is 4 diagonals that we traveled. And it is a perpendicular path because the slope is a negative reciprocal. So that's how you graph over the line y equals x. Let's look at if there's a pattern for graphing over the line y equals x. The input for the function here is A is at negative 4, 7. B is at negative 2, 5. And C is at negative 6, 2. So the output for the function is A prime is at 7, negative 4. B prime, and I'm just writing the coordinates for each of these guys, the primes. The coordinate for B prime is 5, negative 2. And the coordinate for C prime is 2, negative 6. So let's look and see if there's a pattern here. What did I do to negative 4, 7 to get 7, negative 4? What did I do to negative 2, 5 to get 5, negative 2? What did I do to negative 6, 2 to get 2, negative 6? Well, it looks like a flip-flop, doesn't it? So xy would map to yx. You just change the y and the x. So this is a pattern for reflecting over the line y equals x. So let's try that over here. We're going to graph the reflection of the line y equals x for this shape. Again, number 2 is a separate situation. So let's look up here. Let's use a ruler for this. Don't freehand this. Let's get that line of reflection drawn. There we go. And now let's reflect each point. So you've got your line of reflection. Watch me work on, I'll do point D, and then maybe you can do the rest. So for D, I'm going to travel at a perpendicular path, which means a slope of -1. So down one to the right one, down one to the right one, down one to the right one. Here's my path. And I went 1, 2 diagonals. So I go 2 diagonals. D prime is right there. If you're doing C, travel at a -1 to the right one. There's a 1 diagonal, so I go 1 diagonal to get C prime. Do A and B, and then press play when you are finished. 1, 2, 3. That's 6.5 for A. Half. 1, 2, 3, 4, 5, 6. I'm getting A prime right there. B prime is 1, 2, 1, 2. Here's B prime. So let's graph this. That wasn't the best line. Oops. Oh dear. We'll just leave it like that. Okay. I just graphed to the wrong point. That's what I did. I'm so sorry. There it is. I knew that looked bad. This looks much better. There we go. I went to C instead of C prime. All right, so we've got that reflected over the line, y equals x. And it does look like it's reflected. It looks like it flipped over that line. If this were on paper and I folded, the fold would be the line y equals x. So that's how you graph over the line y equals x. If we are using our coordinates, we're going to use the pattern, which is xy maps to yx. We're just going to flip-flop them. So if A is at -7, -4, A prime would be -4, -7. If B is at 0, 1, B prime would be at 1, 0. If C is at 2, -8, then C prime is at -8, 2. We just flip-flop those. That is nice and convenient. So let's go to the next page. We're going to go up here. You can use the equation for the line of reflection. We're going to reflect over the line. This is one way of writing it. Reflect, capital R, over the line y equals x. So first, pause the movie. Try this on your own. Press play when you are finished. All right, let's get that line y equals x drawn. Here it is. Let's graph each point as a reflection over that line. We're going to travel at a negative path. That's 1, 2, 3.5 diagonals. 1, 2, 3. Oops, 3.5 is down here. There's A prime. C is down here, so it's going to go 1, 2, 1, 2. It's going to end up here, C prime. And then B is 1.5, 1.5 is down here, B prime. So when you're connecting these, it's going to look like this. Oops. So that's that one. The original looked like this. And so does the green and the blue, does it look like a reflection over the line y equals x? It certainly does. Writing our coordinates for the points, we get that A prime is at, what is that, 2, -5. We get B prime is at 5, 2. And C prime is at -1, 3. Okay. You can also, some people will just write the coordinates for A, B, and C, and then do the pattern, which is xy maps to yx, and use that pattern to get the coordinates, then graph it. That is an option. We've got one last one. This one's a little different. Y equals -x. So this one has a slope of -1. So the slope is -1 and the y-intercept is still 0. So down one to the right one, down one to the right one, down one to the right one. The line is actually this line. And that's the line y equals -x. And we're going to reflect over that line. Well, that is no problem because the slope that would be of the line perpendicular is a slope of 1. So for A being here, it's going to travel a slope of 1, which is equivalent to -1 over -1, which is negative to the left 1, down 1, to the left 1, down 1. So here's the path that A will travel. And it's 1.5 diagonals. So we've got A prime is over here. B is up here. It's traveling at this perpendicular path of 1, 2, 3.5 diagonals. Half, 1, 2, 3. B prime is right here. C is down here, so it's going to travel up there at 1, 2.5 diagonals. Half, 1, 2. C prime is here. So let's get this drawn. And I'll highlight the original. Oops. Okay. Does that look like a reflection over the line y equals -x? It certainly does. And our points will be A prime, that looks like -5, 2. B prime, -3, -4. And C prime is at 4, 1. And that is part 1 and part 2 of reflections. Thanks for watching.